Hey there everybody, and welcome to your last instructional video from me for the year. You will have the practice test next, but I'm going to include a video from my colleague, and I know some of you use those videos and some of you don't, but for my videos, this is my last one for the year, so thank you so much for having tuned in. I hope you learned a bunch, and I just really appreciate you guys. I'm going to miss you guys. So let's get started. I can statement. I can find the mean, this is going to sound crazy, the mean absolute deviation. If that sounds a little bit familiar to you, there was one of these problems in that practice rise test that you guys took. So if it's ringing a bell, that's probably why. We can abbreviate mean absolute deviation to be MAD. Sometimes you'll see that. So whichever way you want to say it. First of all, as a warm-up, let's talk some about absolute value. I don't believe we've done a whole lot of absolute value in our class so far this year. So first of all, what does absolute value mean? The definition of absolute value is the distance from zero. So that's what it means, the distance from zero. So like if you had the number 1, here let's draw a number line. Here's a 0, here's a 1, here's a negative 1. Okay, so if you had a 1, what would the absolute value of 1 be? How far is it from 0? Well, you're 1 notch from 0, so the absolute value of 1 would just be 1. What would the absolute value of negative 1 be? Well, it looks like you're 1 notch from 0 that way, and so the absolute value of negative 1 would also just be 1. And a good shortcut way to think about absolute value, I know it sounds kind of complicated, but really in absolute value you just take any number that you have and make it positive. So if it's negative, make it positive. If it's already positive, leave it positive. If it's 0, just leave it as 0 because that's right in between both. Let's do a few sample problems. You see how I've written these numbers with these big bars beside them? That is the symbol for absolute value. So what would the absolute value of negative 3 be? Well, like we talked about, if you have a negative number, you're just going to make it positive. So the absolute value of negative 3 would be 3. Okay, what about 16? What's the absolute value of it? Well, it's already positive, so we're just going to leave it positive. So it would just be 16. And the absolute value of 0, like we said a second ago, is just 0. So there's a little crash course in absolute value, or a little review of it anyways. Let's go on to part B. Why is absolute value always positive? Because distance is positive. You can't really run negative half a mile, right? You can run it in this direction or that direction, but you can't run negative distance. Distance cannot be negative because distance is always positive. And I'll just abbreviate that with a little plus sign there. Distance is always positive. Okay, what does the word deviation mean? Deviation. Okay, so like say you're driving with a set of directions and you're supposed to go a certain course. If you take a wrong turn and you get off course, you've deviated from the course. Or like if you're given a certain set of instructions and you do something besides what the instructions say, then you have deviated from the instructions. So to deviate is to kind of go off course. So the word deviation means kind of off course. I know it sounds like a bad thing, but in terms of statistics, it's just kind of a word that describes how far away from middle you are. So not you are, but your data point is, right? How far away from middle the data point is. So that's not necessarily bad or good. It's just farther from the center, farther from the average. Okay, let's go on. We have talked about a lot of different ways to analyze data. Two very common measures we might be interested in are measures of center. Measures of center, we'll talk about that in a second, and measures of spread, and we'll talk about that in a second. So just to review, your measures of center are things like mean, median, and mode. Those are your measures of center. Measures of spread, on the other hand, are things like range, quartiles, and interquartile range, which is what we abbreviate as IQR. Statistics is the science of making decisions using data, or at least the science of arranging the data in a good, intelligible way so that people can make decisions based on it. While the statistics mentioned above are important, they're not sophisticated enough for some decisions that have to be made. Sure. One way we can measure spread that is a little more sophisticated is by computing the mean absolute deviation, the MAD. The MAD. By thinking about the words, we can understand what this measurement is. Yeah, okay, so let's analyze these words a little bit. Mean, well, we know that means average, right? What does absolute mean? In terms of math, it can mean the distance, right? And that's what we're thinking about here, the distance. Because the absolute value of something is the distance from 0. What about deviation? So this says departure from the mean. That's basically what we're going to write here. The deviation is going to be the average distance from the mean. Okay? All right, let's learn how to do this. The mean absolute deviation is a measure of how much variability there is in the data set. How much variability there is in the data set. We're going to look at that more in a second too. In other words, on average, how much does the data vary from the mean? It's a little more complicated to compute than range or quartiles, but that's what makes it more useful. Sometimes the more complicated things are just more useful. This will also help you understand some more complicated measure of variation called the standard deviation, and that is something that you're going to be learning in 9th grade. Okay, so let's do a few of these so we can see what's going on. It says to compute the mean absolute deviation by completing the table for each data set. All right, let's do this together. So I'm going to take these 4 numbers here. I don't have to put them in order or anything, which is kind of nice, right? And I'm just going to fill them in under where it says data. So I'm going to do 3, 3, 5, 5. This table was made with an extra row, so I'm just going to cross that off. We don't need it. Okay, now what's the mean of these 4 numbers? Well, I know how to figure that out. First of all, what's in? What's the number of numbers? How many numbers do I have here? 1, 2, 3, 4, right? Okay, and now let's add them up. 3, 6, plus 10. It looks like it's a total of 16. So if you recall, to find the mean, you're going to take the total and divide it by n. So for the mean, you're going to do 16 divided by 4, and you're going to get 4. And this should be a number that makes sense. Like we've got 3s and 5s, and is 4 close to both 3 and 5? Yeah, it is. It's right in the middle. If I had gotten like 134, that wouldn't make sense for our mean here because that's nowhere near the numbers that I have. So in this case, our mean is 4, and that is what I'm going to put in all 4 of these boxes. 4, 4, 4, and 4. Okay, now let's figure out our deviation. To figure out our deviation, here's what we're going to do. We're going to do data, in other words, whatever's in this box, and from that we're going to subtract the mean. Okay, so we're going to go 3 minus 4 here. What does that equal? That's going to be -1. All right, same thing here. Looks like it's actually the same numbers. 3 minus 4 is still -1. What about over here? We'll do 5 minus 4, which is going to equal 1, and then 5 minus 4 again still equals 1. All right, now let's do the absolute deviation. So just like when we were doing the absolute value up here, we're going to take any negative numbers and make them positive. And we're going to take the positive numbers and just leave them positive. Let's do that. So absolute value of -1, no, well, yes, but we're going to call it the absolute deviation because what it is the absolute value of the deviation. Okay, so absolute value of -1 makes an absolute deviation of 1. This -1 is also going to become +1. This one and that one, well, they're just going to stay +1. Okay, so there's our absolute deviation. And now what we're going to do is basically average the absolute deviations. In this case, you might be able to look at them and just know, oh, the average is 1, but let's go through the process and just know the steps. So we're going to add these up, 1, 2, 3, 4. And then to find the mean or the average, we need to divide by the number of numbers, divide by the n, which is still 4. So that's going to be 4 divided by 4. So the mean absolute deviation is going to be 1. Okay? So let's do another group of numbers so we can get a little more practice at this. So this time we have these numbers. Let's put them into our data column. 0, 2, 3, 7, and 8. Okay, how many numbers do we have? We've got 5. What is the total? Because we need to figure out the mean, so we need to add these up. So let's see, 2 plus 8 is 10, and 3 plus 7 is 10, so the total is 20. And now we're just going to go total divided by n, which is going to give us 4. 20 divided by 5 is 4. So this 4 is the mean, and we're just going to write that here. Notice it's the same mean we had over here. That's kind of a coincidence, but it's also kind of on purpose because I'm going to show you something else in just a second. All right, it's time to do that deviation, and as you may recall, that means we do take the data and subtract the mean. So here we're going to go 0 minus 4, which is going to equal negative 4. Then we're going to go 2 minus 4, which is going to equal negative 2. And then 3 minus 4 is negative 1. 7 minus 4 is a positive 3. And 8 minus 4 is a positive 4. Okay. For the absolute deviation, we're just going to make everything positive because we're taking absolute value here. We're figuring out the distance from 0. So positive version of that is going to be this. Positive version of that is going to be 2. Positive version of that is going to be 1, and then just 3 and 4. Okay, guys, we're getting there. Next, it says sum, which means we're going to add them all up because we're working on averaging these numbers, right? So 4 plus 2, 6, 7, 10, 14. Let me just check that that's right. 8, 10, 14. Yes, okay. So our sum is 14, and our n is still 5. That won't change. It's still 5. So 14 divided by 5, what's that going to equal? I have no idea. Let me ask my calculator. 14 divided by 5 equals 2.8. And that's totally fine that that's a decimal. Let's just leave it as a decimal. They are easy to use and work with. So 2.8 is our mean absolute deviation for this data set here. So what do you notice about these data sets? We've already established that they have the same mean. When you look at them, which one has more variability? The 3355 or the 02378? This one seems more variable, right? We've got a lower low end and a higher high end. The numbers just seem more spread out. So it seems like the mean absolute deviation should be bigger for this data set than for that data set, right? And let's look at what we have. 2.8 versus 1. Yeah, it all adds up. The mean absolute deviation is definitely higher for this data set than for that data set. So if you ever see this number as being higher, you'll know that the data is more spread out. Whereas if it's a lower number, the data is more clustered together. Okay, and then it says, what do you notice about the mean and the variability in the data sets above? Oh yeah, that's what I was just talking about. Okay, let's go on to example 1. It says to draw a dot plot for each data set in example 1 above. Okay, so dot plot time. This is going to be 1A. So we've got 3, 3, 5, 5. I'll just put 3, 4, and 5 on here. Okay, so 3, 3, 5, 5. There's nothing into the 4s, and I'm done. Let's do 1B. So we've got a few more numbers here. We've got 0 through 8. Okay, looks like we've got 1, 0, 1, 2, a 3, a 7, and an 8. Oh, and you can't see that, can you? Let me put it like that. Okay, so just looking at the dot plots, you can really see that the data is more tightly clustered here and way more spread out here. So that is the point of that. Let's go on to the next page, which is almost blank, but that's because they just want us to do this all by ourselves. It says to compute the mean absolute deviation here and show all your work. Okay, so let's do this. In the first column, and in fact, if you want to like pull one of these out for reference, you can, just so that you know the 4 to write. That first column is going to be data, and then you're going to have mean. After that is going to be your deviation, and after that will be your absolute deviation. And 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Looks like I need to extend my lines a little bit. Okay, so let's get our data put in the graph. We've got 75, 95, 80, and again, you don't have to put these in order, which is super nice. 110, 88, 120, and 180. Okay, so what's step 1? Step 1 is to find the mean of all this data. How many data points do we have? 1, 2, 3, 4, 5, 6, 7. So n equals 7. let's total them up with our calculator. 748 is what I got. So that's your total. You take your total and you divide it by n, which was 7. And you're going to get 106.8. It looks like it's 8.5, so we're going to round that up to 106.9. In fact, you know what? Let's just make this nice on ourselves and let's say 107 because it doesn't really say what to round to. So 107 is our mean. Now take a look at the numbers. Does that make sense? It's a lot higher than 75, but it's a lot lower than 180. We've got a fair number of numbers on either side of 107, some higher, some lower. So it looks like we did a good job. And the number does make sense. Okay, so now for deviation, totally fine if you just want to use your calculator and cruise through these. We're going to go data minus mean. So starting out with 75 minus 107, negative 32. Now 95 minus 107, negative 12. 80 minus 107 is going to be negative 27. And if you guys want to pause this video and continue it by yourself and then check back in to see if you got it right, I think that's awesome. You're always welcome to do that. 88 minus 107, negative 19. 20 minus 107 is 13. And finally, 180 minus 107 is going to be 73. All right, so now here's the easy part. Let's find our absolute deviations. So take all these numbers and just make them positive. 32, 12, 27, 3, 19, 13, and 73. Okay, if you remember, we need a couple more boxes down here. There's going to be one here for sum, and then there's going to be one more here for the mean absolute deviation. All right, let's add these numbers up. 32 plus 12. I got 179. And we have to just now divide that number by n, which hasn't changed. You can count them up again, but we have it written down over here. It was 7. So 179 divided by 7 gives us 25.6. We'll round that 5 up. So 25.6. So what does that tell us about these numbers? It means that there's quite a bit of spread. They range a lot. The mean absolute deviation is over 25. So there's a lot of variation from the mean, which if you look at the data set, that's true. Like 180, that's a lot higher than 107. And 75, that's a lot lower than 107. So that all makes sense. Let's take a look at your assignment for tonight, for today, for this morning, whenever you're doing this. I just want you to do the first page. I feel like that is enough. You do not have to do the second page. So if you printed that out, feel free to crush it up and throw it away. Thank you so much for watching, you guys. If you have any questions or any concerns or anything like that, let me know. I love to hear from you. And I don't know if I'll see you next time, but thank you for watching. It's been a great year. Bye.